Hello gentlemen, welcome back. In this video we're going to look at finding the area of oblique triangles. We'll come up with some different equations for that, and we'll do a practice problem, and then we'll move on to the law of cosines in the next video. So this one should be pretty quick, so let's get started. As you guys know, the area of a triangle is equal to 1/2 base times height. So I have a triangle here, and what I'm going to do is I'm going to look to describe my height. First I'm going to use angle A right there, and I can write that the sine of angle A, so the sine of A is going to be equal to H over B, okay, because I'm looking at this triangle right here. It's a right triangle, so I can say that my H here is equal to B sine of angle A, and what I'm going to do is I'm going to plug that in for my height right there. And my base in this particular instance is going to be C. So the area of the triangle here can be written as 1/2 base, which is C, times B sine of A, like this. And this part right here, this is my H, okay? And that is my base right there, okay? And so I just described this area of this triangle with sides B, C, and the included angle A. I could have also just as easily used angle B over here, right there. And I could have said that the sine of B was equal to H over A, or H is equal to A sine of B. And let's write that up, because we can do that as well. If we do it like that, again, C is still my base. Right there is my base. But now my height is described like that. So these two statements right there are equivalent. So I could use this to solve for the area of the triangle. Okay, again, it's all dependent upon what information is given. I could have dropped a different perpendicular. If I draw this as my perpendicular, I can use angle C up here. Right there. And I can say that the sine of C, let's do it right here, sine of C is equal to the opposite side, which is H, over hypotenuse, which is A. And so I could have got here, I could have got H is equal to A sine of C. And I could have used that, but this time my base would be B, okay, because my base would be on this side. So I could have wrote here that my area was 1/2 B times A sine of C. Okay, so this, in this situation, that's my base, and this is my height. Okay, base here, base. Okay, like that. Okay, so in general, what I have is I can say the area of any triangle is half the product of the lengths of two sides times the sine of their included angle. So area of the triangle is 1/2 AB sine of angle C, or 1/2 AC sine of angle B, or 1/2 BC sine of angle A. So using the two sides and their included angle when you're finding the area of the oblique triangle. Let's do a quick example. Find the area of a triangle with B is equal to 130 degrees, A is equal to 62, and C is equal to 20. In that situation, we're going to use this part of the formula right there, because I'm given side A, I'm given side C, and I'm given angle B. Okay, so that's going to be a straight plug-in right there, and if I do that, I get 474.9. Okay, this is just a simple example. These are pretty straightforward. Typically, you have to use the law of sines or eventually the law of cosines to find other parts of the triangle before finding the area, but the area formula is pretty straightforward. Here's read pages 434 435. These examples go over finding the area, and then there's more problems. Some of these involve the law of sines, some of them involve doing some areas of triangles. Okay, so that we got one more section to go. It's on the law of cosines, and then week 5 will be done. So if you guys have any questions, make sure you're emailing me so we can get those squared away as we head towards the final. Thanks, fellas. Have a good day.